All right, hello everybody. This is the video recording for the Introduction to Research lecture in the Quantopian lecture series. And as always with these videos, I am going to show you how to get to the lecture series. So one of the ways is to type www.quantopian.com/lectures into your browser. The other way is if you go under Learn and Support, Learn, and then go to Lectures. So the lecture we're going to be talking about today is number 1, Introduction to Research. So research is the research environment in Quantopian, and I'll show you what that means. If you haven't seen the research environment before, it is based on the IPython Notebook, now known as the Jupyter Notebook. And IPython Notebooks are combinations of code cells and text cells, which is really powerful. So for example, here I have a text cell, and if I double click on this cell, you can see, well, it's just text with a little bit of formatting. So you can see these hashtags make titles, and if you execute a cell using the play button right here, I'll run it, it'll render that cell and make the text nice and readable. The other way you can execute a cell is by hitting Shift-Enter, just like that. So I'm going to use Shift-Enter a lot, so if it looks like cells are executing by magic, that's probably me just hitting Shift-Enter. And I encourage you to learn that command too. The other commands are up here on the control bar. They should be pretty intuitive. Save your notebook, save it often. Make a new cell. So when you make a new cell, you can choose what type of cell it is with this drop-down menu. So if it's a code cell, you can see here I just have 2 plus 2. I'll replicate that in this cell. So 2 plus 2, and I execute. That gives me 4. Great. But if I want to make it a text cell, I switch to Markdown. Don't worry too much about these other 2 types of cells for now. I rarely use them. The 2 important ones are code and Markdown. And remember, Markdown is just the text formatting language. So here's 2 plus 2, and if I render that cell, it's going to be rendered into text. The other really nice thing is that you can have, for those of you that are familiar with LaTeX or LaTeX or however you'd like to pronounce it, LaTeX math formulas, you can put those in. So here, I'll put in a LaTeX math formula, and I'll put in a display mode formula, and we'll say 2x squared plus z sub t or something, whatever you want to say. So, and you'll get this nicely rendered math. It's really useful because what it allows you to do is it allows you to write out documentation for your analysis right next to your analysis. And it's really taking off. Notebooks of these form are taking off in research and in industry. If you're familiar with LIGO and the recent discovery of gravitational waves, they released all of their analysis, documentation, and code to rediscover gravitational waves if you want to, in IPython Notebooks, and you can look it up. If you look up LIGO, L-I-G-O, IPython Notebooks, they're really cool. So these are useful because they're self-contained things. If you send someone an IPython Notebook, they have the code to run some analysis, and they have the documentation and the motivation for the analysis. It's really kind of a self-contained unit that allows researchers to work really effectively. And so we'll show you some of the ways that you can do that here. So again, we've just been over executing a command. And so now we're going to go ahead and execute this cell, which you've already seen, but we'll do it again. 2 plus 2 gives us 4. Great. So that's a code cell. It evaluates what's in this cell. Now, sometimes there is no result to be printed. And you can see that, as is the case with assignments. So if we evaluate this cell, we don't get anything. Now, why is that? Well, only the last line is printed in a cell. So in this case, we'd print the last line. But in this line, the last line in the cell, x equals 2 doesn't return anything. So we have nothing to print. So nothing is printed. We'll see an example of this. 2 plus 2, 3 plus 3. You can see it prints out 6. And that's because 2 plus 2 is evaluated, but we're not storing the results anywhere, and we're not printing the results anywhere. On the other hand, the last line of the cell by default is evaluated. That's 3 plus 3. That returns 6, so we return 6. Another important thing about notebooks is that memory space is basically kept between cells. What do I mean by that? Well, we set x equals 2. You'll see this a little more in the notebook. I'm just going to stress it now. We set x equals 2. So if we made a new cell and we said x, we're going to get 2. So if you do something in one cell, it affects all the other cells as well. That's really useful, but just remember that because it can also be a source of bugs, right? So if you make a list of cells that you evaluate in a certain order, and then in your analysis you forget about one cell that like updates a variable that you need, sometimes you'll accidentally run that cell and overwrite a variable that you needed or whatever. There's a lot of ways in which bugs can come out of this. So just be aware, remember that cells affect other cells. All right. So if you want to get at the result of something that's not in the last line, well, here's an easy way to do it. You can just say to print that line. And there we go. So we have now 2 plus 2 is 4, 3 plus 3 is 6. Here's another important thing about research. You want to know when a cell is running? Well, when a cell is running, there's going to be a star on the left. So you can see here it has yet to be executed, which means it's got this nothing displayed right here. And then we'll run this cell. You see the stars there, and then after a little while, it finishes and prints out whatever the sum is of that series that we made. And so we'll just do it one more time so you can see. It's going to be a little fast. There you go. Takes about 1 second to run. And while it's running, you can see it has a star. This is useful because sometimes you'll have slow commands. You can know what cells are running in a notebook which haven't finished yet, especially if you're running cells out of order in a more complicated analysis. And as always with these notebooks, I strongly encourage you to follow along with your own notebook while I'm doing this. So if you want to go to the Quantopian website, get a copy of your lecture, follow along. If you have the video running on one side and the lecture running on the other side, maybe you have 2 screens. That's, I think, the most powerful way to learn this. And then what you can do is you can pause the video and start messing around. Change this number. Change what's calculated here. Change these print statements. As we get more complex, there'll be more opportunities to mess around and try stuff on your own. In my experience, that's the really effective way to learn this stuff. So here's the next subject. Importing libraries. So the vast majority of the time, you're going to need stuff that's, not default in Python. And so there's lots of pre-built libraries that have lots of useful functionality. For example, NumPy, numeric Python, is a really important and common one. And pandas. This is a data processing library actually written for finance. It's really powerful. We're not going to get to see too much of the power today because this is a really introductory lecture. But take my word that this is a really useful library that is going to save you a ton of time. And then finally, we have a plotting library. Again, don't worry too much about the syntax of this for now. Just kind of accept it. Say this, okay, this thing works. We have it. And then as you learn more about Python, if you don't already, you'll understand what's going on here. The important thing to note is that the as imports stuff as another name. So let's see what that looks like. So if we were to just import NumPy, we would have access to NumPy. And we would be able to say NumPy, and then we would say numpy.mean of a short array, 1, 2, 3. Execute that cell. And there's the mean, too. But let's say that we wanted to call it something else. We import NumPy as cool stuff. We could also do that. And now we could just say cool stuff.mean. So all it's doing is it's changing the name. And you can see here we're importing these libraries as these shorter names so that we don't have to type out this long thing every time we want to do useful stuff. So here, now I can just do NumPy mean of a short array. Don't worry if you didn't understand that syntax yet. You should hopefully understand it more and more as you go through these notebooks. So the next really useful thing is tab autocomplete. This is maybe the most useful thing in this notebook. Tab autocomplete allows you to get access to stuff and see what's available in a library. So you can see if I type a dot and then tab, it shows me all the suggestions. And if I start typing out something like normal, it will start narrowing. You can see I made a mistake there, so it stopped narrowing it down because it didn't know what to do. But if I start typing out normal, it'll show me the options that are left. Or if without pressing tab, I just type norm and then tab, you see how it auto-completed it. I'll do it one more time. If I type out nor or no, hit tab, there's the options that are left. If I get to something where it's unambiguous, it'll just finish the word for me. So my recommendation is just to be constantly hitting tab as you're writing. There's no loss. If it's unambiguous, it'll just finish your word for you. And if it is ambiguous, it'll show you some suggestions. Either way, you're gaining information or getting something done faster. So next question. OK, we've just found that there's this thing called numpy.random.normal. What does that even mean? What is that, right? So here's how we can check that. Getting documentation help. This is a really important one. If you put a question mark after an object in Python, it'll return to you any documentation that Python has about that object. Specifically for advanced users, it's returning the doc string, but we're not going to worry about that too much right now. So let's execute this cell. And there you go. You can see it's returning this documentation of this function. How do we use it? What does it do? What are the arguments that we provide to it? What are the outputs? Some references you can read up. It's really useful. It gives you pretty complete information, and it pops it up in this nice little pop-up so that you can kind of continue your work and maybe type some stuff up and try using the function while reading the documentation. So it's a really powerful tool. Tab complete and question mark notation I use all the time because I don't remember what everything does. I just trust Python to remember it for me, and then I use the question mark to remember what stuff does. So we're going to use that function now. We're going to sample some random data. So we're going to draw data from a normal distribution. And if you are unfamiliar with sampling data, there's some other lectures in the lecture series that discuss this, specifically random variables. Or you can look up on online what is sampling data. But the general idea is that you have some distribution of possible data, and you draw randomly from that distribution. So a normal distribution is parameterized. It says, where is the center of the distribution? So where is most data going to come from, basically? How wide is the distribution? So how likely is it that you get extreme values? And how many points do we want to sample? And you can see that because it says in the doc string the location of the distribution, where it is on the x-axis, the number line, the scale, that's how wide it is, and the size of our sample. So in this case, we're drawing 100 points. So let's draw 100 points. OK, so now x should have 100 points in it. And you can check that if you want to. So we'll just evaluate x. That's what x looks like. Great. It's 100 random numbers. You can see if you could easily change this to 10,000 random numbers. There's a lot of numbers that it's not displaying. You see it's automatically cutting this down so it doesn't overflow your screen. So we'll go back to 100. And now something that's really useful is being able to plot stuff. So let's go ahead and plot it. We'll say plt. Remember we imported plt. Well, plt.plot is all in there for us. But remember, you could use tab autocomplete to find out what that was. So you say tab plt dot. OK, what's in there? There's lots of interesting stuff. You could look through this, draw. I don't know what that does. Let's check it out. OK, there's some information on it. But plt.plot, question mark notation. What does it do? OK, well, here's some example use cases. Plot x and y. Plot just the y. OK, so here we just want to plot x. So we want to plot x on the y-axis, which is a little confusing notation-wise. But let's go with it. So we'll plot x. There we go. That's x. Let's do it a few more times with different random samples. Let's plot x with more points. Again, this is the type of experimentation that I think it's powerful to do if you're following along in your own notebook. Just, get a sense. What's happening here? Break it apart. Mess with it. See what happens. Lots more points. Very dense graph. Let's go back to 100 so it's more manageable. OK. So one thing you'll notice is that, what's this here? Well, plot draws something on the screen. but it also returns a plot object in case you want to modify that object later or do something interesting with it. So it returns this plot object, and it prints it out because it's the last line in the cell. Let's test that theory. plt.plotx, and we'll say 2 plus 2. OK, so that's the theory is seemingly confirmed. The last line of the cell, plt.plotx, was returning this weird object. So what can we do about that? Because that, that looks kind of gross to have that there. I don't want that there. Well, you can squelch line output. You can have it not print by using this semicolon. So let's try that. And yep, no gross line here. So this can be very useful. Another thing is that if you have a very large plot or a set of plots, you can press this and it will turn on or off scrolling for that cell. This is really useful to know if you want to be able to display a lot of stuff on your screen at one time. So here's scrolling off, or scrolling on rather. I can look at the plot like this. Here's scrolling off. I can see the whole plot at once. So just be aware of that. So now let's add some axis labels. You got to have axis labels. So we'll now have 2 x's. We'll have x and x2. And we're going to plot both of them. They're both sampled from random data. And then we're going to make plot.xLabel, which sets the x label on the plot. And we're going to make plot.ylabel. You can see it's time and returns, let's say, returns on some asset. And in general, of course, you want to add a unit. In this case, it's like unitless data. So you might want to say time in seconds returns in percent or something, or dollars or whatever it is you're plotting. And then finally, legend. Legend takes in an array. And the elements in the array are the names of the different series you plotted. Again, you can use the question mark notation to check this. Let's execute this cell. Now we have 2 series and some nice labels on the plot. OK. So plotting stuff is well and good, but one thing I always say in my more advanced lectures is that you should be very careful of using plots to convince yourself of anything. And the reason for that is that humans are very visual creatures, so we're really good at seeing patterns. And beyond seeing patterns, we're also very good at only seeing information that confirms what we already want to believe. This is a well-documented psychological phenomenon. So when you're looking at plots, you're all too likely to just see the patterns that confirm your theories and ignore the rest. So a lot of times what statisticians will want to do is they'll want to use statistics to get at the properties that they're interested in without looking at a plot necessarily. It's okay to look at a plot and look for reasons that you might be wrong, but it's dangerous to try to convince yourself that you're right using a plot. So statisticians will often use plots as warning signs, like maybe their data doesn't look like they think it did, or maybe there's a weird bug in the data where you don't have data for some time series, and that might be missed if you're just doing a mean and it's all zeros. So that's an example of what you might use a plot for. But here we're going to take the mean, that's just the simple average of x. So we'll execute that. We'll take the standard deviation. And OK, but that was for simulated data, and this makes sense because we drew it from a distribution which had a 0 mean and a 1 standard deviation, so these are both pretty close. And you can see that if we were to generate x using way more samples, well, not way more, but 2 orders of magnitude more, what you'll see is that the mean and standard deviation will be much closer to the values that we chose on average. So they'll converge as we have more samples. So let's see an example using real pricing data, because another major feature of the Quantopian research environment is that you can get real pricing data. And so here we're going to get real pricing data from Microsoft. You can also get corporate fundamentals data and other data sets that are available through the data store. I'll leave you to explore that on your own. But you can get pricing data, and so we'll get data from Microsoft here for 3 years, from January 1st, 2012 to June 1st, 2015. So let's get that. And let's print out this data frame. You can see it's going to truncate it, have that ellipsis in the middle again to indicate that we're not viewing the whole data. But you can see it's 857 days, trading days. Remember, we don't trade every day. So 857 trading days worth of data. And 6 columns. And those columns include price, high-low, volume, all these other fields that people generally use. You can also get at minutely frequency data. I'll leave you to use the question mark notation to figure out how to do that. You might want to try doing that now if you're following along on your own time. So the next thing we'll do is we'll just get the price out of data. And data is a pandas data frame. And you can look up pandas documentation to see how to do this. But we'll just index in using price like this. So now X should contain only the price. We can verify that by evaluating it in a different cell. X, great. Just one price series here you can see. And now we'll plot x.index and x.values. What are we doing here? Well, you'll notice that if we looked at X, it's not just numbers. It's not like an array where it's just the first element, the second element. This is a pandas series, and you can check that by doing type of X. Type will tell you what type something is. This is a pandas series object. Well, what do you have in a pandas series object? Well, tab autocomplete. Let's see what we got in a pandas series object. Lots of stuff. Okay, well, let's docstring pandas series object. Oh, lots of interesting documentation. You can look up pandas series on Google, and it will tell you lots of tutorials for how to use this. One really important thing you should know is that it has an index and it has values, so that you can get the values by indexing into the values. And the index in this case are days because it's a daily data series. And you can see here if we plot x.index as the x values and then x.values as the y values in our data in our graph, it'll have the dates on the x-axis and the price on the y-axis, which is already pretty useful. So there's Microsoft over these 3 years. And now let's actually get the mean and standard deviation for Microsoft. And there you go. The next thing we're going to do is we're going to look at how to get returns from prices. So here we're going to say we're going to use the pandas %change function, which is a convenient pandas function that's built into their series objects. So %change, again, use the question mark notation if you're unsure, or Google the name. %change is just going to give us the percentage change for each position compared to the last one. So that's returns, daily returns. The first one is going to be a %change from nothing to something. So that's going to have not a number. It's going to be an error in the first one. So we just drop that first one. And this is notation means take the first element, or sorry, take the second element because Python is 0 indexed. So 0 would be the first element. Take the second element onwards. Colon means everything after that. So to give you an idea, let's break this line down. We're saying x dot %change. You can see I tab autocomplete it because it was unambiguous. Well, there's a nan at that first element because it doesn't make sense. So if we took everything up to the last element, -1, it would be everything but the last. And here we'll take, maybe we could take the 10th, the 11th to the 16th. 5 elements. But in our case, we're interested in 1 onwards. And you can see that gets rid of that first day, which is nan. So that's what that is doing. And it looks like I just deleted that cell. That's OK. We will just say r equals x dot %change 1 forward. OK, we should be set. So now we're going to plot r. But we're going to plot a histogram of r because r is no longer a time series. We want to look at the distribution. Well, it is a time series, but we're more interested in the distribution. So for those of you who haven't seen histogram plots before, this is a histogram plot. Feel free to look it up in your own time if you're unsure. What it just shows is for each kind of range of return values, how many observations we saw. So it's a way of estimating how common different types of returns, different positive or negative sized returns, how common they might be by looking at historical data. Don't assume that this is going to accurately reflect future distribution of returns. Much more statistical validation would be required before you could make a claim like that. But this is the first step in saying, okay, well, historically, what did the distribution of returns look like? And so we can get the mean of the returns and the standard deviation of the returns. So this means that every day there was this percentage change in the price of Microsoft, and this was the variation of the daily percentage price change. And so you can see that the standard deviation is actually much higher than the mean return. So it's a noisy series. Now, what's interesting is that you can go backwards. And remember when we sampled data from a normal distribution? Well, one thing we might be interested in is the distribution of Microsoft returns normal. Is it normally distributed? And the reason we might be interested is because normally distributed is considered well-behaved, and there's a lot of stuff you can do with normally distributed data. So what we'll do is we'll draw from a normal distribution with the mean that we computed and with the standard deviation we computed. And we'll take 10,000 samples and we'll plot that as a histogram. And if Microsoft is normally distributed, you would expect to see that this would look pretty similar, but it doesn't. For one thing, in a normal distribution, you're only going to see returns of 6% in either direction, losing 6% in a day, gaining 6% in a day. With real Microsoft data, you see it all the way down to losing 15% in a day and gaining 15% in a day. So these parameters of mean and standard deviation are not always accurate representations of what's going on in the data due to things like autocorrelation, fat tail risk, all sorts of different things. You can check out the advanced lectures for more information on this. This is more of an instruction on how to use the research environment. So that said, that's an interesting analysis you can do. And then the last thing we're going to do is we're going to make a moving average. A moving average is just the average of the last n days at each point in time. So you can see here we're taking a 60-day moving average. And it doesn't start for 60 days because we don't have 60 days worth of data yet. On the 61st day, we have 60 days worth of data. We look at those 60 data points, we average them. That is the 60-day moving average in that point in time. And you can see here, sometimes people use the moving average as a way to smooth out the data and try to get a sense of what's going on with Microsoft, maybe without all this random noise going on here. And so, you can practice flying around with different moving average lengths. You can even plot different moving average lengths on the same plot. We'll try that here real quick just before we finish up. I'll call them 2, 3, 2, 3, and then we have to make more moving averages. And we'll make them 60 and 90. Whoops. I forgot to label them. So there's an example of an error. These messages are informative. They're going to tell you what's going on. Where did it throw the error? Well, it didn't like this line. Why didn't it like this line? This name is not defined. Oh, because I forgot to define it up here. Well, there you go. Fix the bug. So you can see here, I'm just going to delete this hanging cell. You can see here, there's 3 moving averages plotted on the price. So already we're up to some interesting analysis, Not useful by itself, but certainly the tools are starting to get there. So that's an introduction for how to use the research environment. You can access the research environment by going to My Code Notebooks. And this will pop you into a research environment. You can see I've got lots of notebooks in my research environment. You probably will not have as many. Just based on stats that I've seen about usage of the research environment, I can strongly guess that people watching this video will not have this many notebooks. And you can see there's the one we were just working on. You can see I cloned a different copy of it earlier to practice. And so if we go back to this notebook, that's the one that we were just working on. So you can access it from the menu if you want to under My Code Notebooks. That's all we're going to cover for today. As always, all the lecture series are available on quantopian.com/lectures or going to learn lectures. And we also have workshops all around the place. So at the bottom of the lectures page, you can see the workshops. We run workshops now. We're expanding the program. We run them in all sorts of cities. If you're interested in doing a hands-on, in-person approach to learning this material and see one near you, please feel free to check it out. And if you don't see one near you, you can email us and tell us where you'd like that workshop. Otherwise, feel free to post any questions you might have about the research environment in the community forums. We love to see questions about how to use research there, and we'll try our best to answer them, although other people might answer them. And you can see in the community, any post that has this little notebook symbol attached to it means that it has a research notebook attached to it that you can maybe clone and check out. So here is a research notebook that someone else made. In this case, it's Sung, who's a Quantopian employee. He makes lots of really good tutorials. And you can see someone actually posted their own attachment notebook. So you can look at both of them. Here's a preview of the notebook. Let's look at this guy's preview. And if you're interested in the analysis that person did, just go ahead and click Clone Notebook. You'll be taken to your own copy of the notebook in your own research environment. This is now totally mine. I can do whatever I want to it. And you can see, well, this person did this analysis on Microsoft. But what happens if we change the analysis to, oops, that wasn't executing because you can see that blue thing means the kernel wasn't ready. So let's just redo it here. What happens if we change the analysis to Apple? And let's redo his notebook with Apple prices. Already some interesting stuff. So this is an example of how quickly you can start doing some quantitative workflows in the research environment. One thing I will say is that professional quants are going to spend almost all of their time in the research environment. They're not going to spend much of their time anywhere else because this is where you really develop statistical hypotheses, test statistical hypotheses. It's very fast. You can iterate through many ideas very quickly. You can muck with data. It's much harder to do that when you're writing backtests and developing algorithms because it takes so long to debug them. And you can get at a lot of the same information here. In general, a quant will spend the vast majority of their time in a research environment and then kind of only at the end actually translate their idea to a tradable algorithm once they're very sure their idea works. So in terms of developing good strategies, you probably want to spend most of your time in the research environment. And just based on the usage statistics of Quantopian that I've seen, people who produce productive stuff on the forums, they also tend to use the research environment a lot, just because it enables them to do so much more with the time that they have. So please feel free to check out the research environment, mess with it on your own, clone some notebooks by the forums, just dive in, do stuff that you don't understand, get messy. That's how you learn. And if you have any questions going forward on this stuff, please feel free to leave questions in the community forums. You can, if you're really stuck, you can email feedback@quantopian.com. Or if you have questions specific to the lectures, you can email me at Delaney, DELANEY @quantopian.com. Hopefully you enjoyed this, and let me know if you have any questions or if parts of this were confusing.